Right, penultimate question, trickier binomial one, the one that involves some worse brackets to begin with. Same formula as always. So part A, use the binomial theorem to expand x plus 2 over x, simplifying each term of the expansion. So x plus 2 over x to the power of 4. It wants the whole thing expanded because it doesn't mention anything about limiting anything in the question. So it is x to the power of 4, first term to the power of 4, plus 4 choose 1 times x cubed, so that drops by 1, times the whole thing, 2 over x to the power of 1, plus 4 choose 2 x squared 2 over x squared, plus 4 choose 3 x to the power of 1, 2 over x to the power of 3, and then instead of writing 4 choose 4, it's just going to be the last term, which is just 2 over x to the power of 4. Now, in terms of maybe the best way to simplify this, you may prefer like 2 over x written as 2x to the minus 1, and then this will be something different. That's going to be 2x to the minus 1, then to the power square, to the power 2, then to the power 3, then to the power 4. It's up to you. You may not prefer that. So that's x to the power of 4 plus, now this is 4 times x cubed times this. No, actually, no, I'm going to go back on what I said. I don't really like that, actually, because that ends up being 4 times x cubed times 2 over x. Maybe going to leave it like that for now. And then this next one, 4 choose 2, I think it's 6. Let me just double check that. 4 choose 2 is 6. So it's 6x squared times this all squared is 4 over x squared, plus 4 choose 3, which is 4, times x, times this all cubed, which is 8 over x cubed, plus then this last one, all to the power of 4, is 16 over x to the power of 4. Now, these can all be simplified, because there's a lot of things going on here. Now, this first term is still x to the power of 4. That's fine. Right, okay, first of all, times the 2 on the top is going to give us 8. But then that x is going to cancel one of those x's out there. So that's going to leave us with 8x squared. In this one, the x squared will cancel out, and you're just left with 6 times 4, which is 24. In this one, that will cancel out one of them there to leave me with squared. So that ends up being 32 over x squared. And then the last term is as it is. Okay, part B. In the binomial theorem of a plus 2x to the power of 6, where a doesn't equal 0, the coefficient of the term in x squared is the same as is equal to the coefficient in the term x. Find the value of a. Now, what I'm going to have here is I only need to go up to x squared, because if I do that, I will have the x term and the x squared term, and then we'll maybe notice something and go from there. So a plus 2x to the power of 6. Now, if I expand that, it is a to the power of 6 plus 6 choose 1, a to the power of 5, 2x to the power of 1. That's going to be my x term, because it's just going to be x to the power of 1. Plus 6 choose 2, a to the power of 4, 2x all squared. And that's going to be my x squared. So that can carry on, but I only need them for now. So that's going to give me a to the power of 6. That's 6 times 2, so it's 12. A to the power of 5 x. Plus 6 choose 2, which is 15, times 2 squared, which is 4. So 60, a to the 4 x squared. Now, what they are saying is that the coefficient of the term in x squared, 60 a to the power of 4, this whole thing here, is equal to this, 12a to the power of 5. That's just a job for us to rearrange. Okay, so I can create that equation there. Now I can cancel out a lot of a's in this, because I can cancel out a to the power of 4. If I take a to the power of 4 out of that, it's just leaving me with a to the power of 1. So I have 60 equals 12a, so a equals 5.